In this problem, we are to use differences or ratios to determine if each of the data set is linear or exponential, and then after that write a formula for each. So down here I'd like to write what would be the formula if the data indeed came out to be linear and what it would be if it were exponential. So for linear, we would want to write the equation as y equals mx plus b. So we would have to identify the y-intercept b and its slope. If the data came out to be exponential, then we would be looking for a common ratio, and the equation would be of the form y equals ab to the x. Equation for linear, the m is the slope, and you have to have constant slope for something to be a line. And the b is the y-intercept, meaning it's what you get out when you plug 0 in for the input. And for exponential, the a value is the y-intercept, and the meaning is the same. It's the output that you'd get if you replaced x with 0. And with exponential, because exponential growth and decay indicates a constant multiplier, b would be the common ratio is what we're going to call it in this problem. So going back to the problem here, we have the first set of data. Because the inputs are equally spaced, they go from 0 to 1 to 2 to 3, I can use differences and ratios to determine if it's linear or exponential. So I'm going to start by using differences, and not that you'd have to do it in this particular problem because the arithmetic is easy, but in general, to do differences, what you want to do is take a successive y value, say 41, and subtract its previous. What I want to do is take 41 and subtract 52, and then I'm going to take 30 and subtract 41, and then I'm going to take 19 and subtract 30, and if I get the same number all three times, then I know that this is linear. In fact, in this case, it would be the slope. I'm going to take 19 minus 30, I'm going to take 30 minus 41, so 41, take away 52. Notice that all of the differences come out the same, comes out negative 11. What that means is the data is going down 11 units every time this goes up by 1. So to get from 52 to 19, you could successively subtract 11, subtract 11, subtract 11. So this is linear, and it turns out that's the slope. In fact, if you remember how to calculate slope, it is the change in y values, which would be 41 minus 52. And then in the denominator of slope would be your change in x values, x sub 2 minus x sub 1. So here is the slope, m if you will, for these 2 points, x1, y1, and x2, and this was my y2. So 41 minus 52 divided by 1 minus 0, I get the slope is negative 11 over 1. So you could do this for each successive pairs of points, and you'd find that the slope is constant. In fact, it is negative 11. So that gives me most of the answer to the problem. Notice that it said, after determining whether it's linear or exponential, I am to write a formula or an equation. So for this part, it would be, the output would be p of x, not y, and it would be equal to mx plus b. We just determined that m is negative 11, and the b, again, is what you get out when you plug in 0, and that's not difficult to ascertain in this problem because they're telling me right here, if someone plugs in an input of 0, the output is 52. So that means my b value is nothing more than positive 52. Notice, though, just because it won't take long for me to show you, that if something is linear, it has common differences, provided the inputs are equally spaced, but the ratios won't be. So if I calculate ratios, and again, this makes sense to do so because my inputs are equally spaced, finding ratio means to not subtract successive outputs, but to divide. So had I taken 41 and divided by 52 and 30 divided by 41, and then you could do the third one, but it wouldn't be necessary because even after doing 2 of them, you would notice that there is not a common ratio. So 41 over 52, you'll notice, is not the same thing as 30 divided by 41. One's 0.788, one's 0.731. So this means that even though my inputs are equally spaced, my ratios are not constant, so that means it's not exponential. We already knew that, but I wanted to point out, had you tried ratios first, you would have saw that it's not exponential. So going on to the next part here, g of x, you could repeat the same process and start. I'm going to hit clear by subtracting 64, take away 128, And if it's linear, I should get the same thing as I got here by taking 32 and subtracting off 64. So there would be my differences. And if you notice, the differences are not constant. The fact that the first difference came out negative 64 and the second came out negative 32 means this, that to get from this output to that one via subtraction, you'd have to subtract 64. And to get from this output to that output, you would have to subtract 32. So this is not constant slope. There's not a constant difference, and therefore this is not linear data. The next step to check whether something was exponential is to find that common ratio, which would be b. So I would take the later y value and divide by the former. And that would be 64 over 128, and when you do this on the calculator, you would get a half. You'd get 0.5. And then you would proceed to do that again. So there's the first ratio, and then you would move down to this one, which is 32 over 64. And again, if you need a calculator, you can type that out, but you are indeed going to get a half again. And just to be sure, my last ratio here would be, I'm just going to write it down here, 16 divided by 32. And if you did that on a calculator, or perhaps it's clear, you would get 0.5 again. So we didn't get a common difference, but we did get a common ratio. This indicates that my data are exponential. In fact, what it gives me is the b. It gives me that common ratio. The common ratio of 0.5 means this, that the fact that we divided those numbers and got 0.5 means to get from one output to the next. In this problem, you could do that via multiplication of a half. If you multiplied by 0.5 or a half, you would get from 128 to 64. If you multiplied 64 by a half, that would cut it in half and you would get 32. And then multiplying 32 by a half, it would cut it in half and you'd get 16. So you can even see in the data that the data is going down. Every time x goes up by 1 unit, the outputs get cut in half. So my equation is going to be some number a, and my b we just figured out to be 0.5, or if you want to write that as a half, that would work as well. And it's being raised to the x power. My input was indeed labeled x. Now I need to only ascertain what a is, the number here. And a was like the b in linear. It's the y-intercept. It's what you get out when you plug in 0. So if you look at the data set, that's sitting right here. It says if you plug in x equals 0, the corresponding output would be 128. So you would put a 128 here, and if you had the time, you could check this answer by simply going back now, plugging 0, 1, 2, 3 into them to see that you get out these numbers. And likewise over here, you could check p of x, that answer, by replacing x with 0, 1, 2, and 3 and seeing that they indeed give you these outputs. So last but not least, we should do h of x, and I'm going to start with differences. So with differences, again, you would do 1, 1, 0, 0 here, and you would subtract off 1,000. And then the second one would be to take 1,210 and subtract off 1,100. And then lastly, 1, 3, 3, 1, and you would subtract off 1, 2, 1, 0. If these data are linear, then you would get the same number each time here. And again, you probably can do this calculation in your mind, but if the data were uglier, say, you would need to use a calculator to make that calculation more efficient. So the first difference is 100, and the second difference comes out to be exactly 110. So already I need to go no further. This means that the data is not linear. So if you look at this, you can even see that to get from 1,000 to 1,100, you would have to add 100 to get from here to here. Then to get from this output to this one, you would have to add 110, and that's why this difference came out to be 110. So clearly we do not have constant slope. In fact, because the inputs are going up by 1, and if they weren't, I would be telling a different story, but since they're going up by 1, the slope between this point here and this point here would be 100, and then when you looked at this point here and this point and found its slope, it would be 110. You do not have constant slope. So I am hoping that we will do ratios now and get that this is exponential. So the ratios would be, same thing, you take the later number, 1100, but since I'm doing ratios, that means to divide. the former output of 1,000, and we should get the same thing if it's exponential here that you'd get if you took 1210 and divided by 1100, and then lastly would be 1331 and then divided by 1210. So 1100 divided by 1,000 gives me this ratio of 1.1. The next one, and you will see that that indeed also returns a ratio of 1.1, but to be absolutely certain, I'm going to go very last problem and do that ratio, and indeed I get 1.1 again. So back here, all of those ratios are 1.1, and if you want to know what that means is every time x goes up by 1, your output can be found by taking the old output and multiplying by 1.1. By doing division, what you've uncovered is the constant multiplier. So I'm going to write that down. We tend not to call a multiplier because we have a different word in math, the growth factor or the decay factor. Nonetheless, whatever you call it, these are indeed the b value in the equation. We found that the b value was 1.1, and now we need to figure out what the a value would be, but it's the same as the other problems. It's the output that you get when one plugs in 0, and they were nice enough to give that in the data set. It says right here, if someone were to replace x with 0, the output would be 1,000. So you might think of that as the start value. So by putting 1,000 here, just like the equation indicates, the y-intercept, or the output you get when you plug in 0, is a. This would work. If someone were to replace x with 0, you can try it on your calculator, you would see that they'd get 1,000. And if you haven't already, some point you should probably check these results. So for example, if you've got the time, actually take your equation that you just wrote and start checking it by plugging in these inputs. So I'm thinking the equation is 1,000 times 1.1 raised to the x. If I were to replace x with 0, my equation says I should get out 1,000, and indeed I do. In fact, let me press second enter, back arrow over, and change that to a 1. And if my equation is correct, replacing x with 1 should give me 1100, and you can continue on this way and check it for 2 and 3 to see that it is indeed exponential.